everyone, I'm Fira from the Lawrence Hall of Science, and this week I'm thinking more about exoplanets. In our last video, we learned that exoplanets are planets outside of our solar system. We learned some of the ways that astronomers look for exoplanets, like the radial velocity method and the transit method. And today, let's talk about some of the different types of exoplanets that astronomers have found. One of the most common types of exoplanets discovered are hot Jupiters, which are extremely massive planets orbiting very close to their host stars. Hot Jupiters are gas giants with masses comparable to the planet Jupiter in our solar system. However, Jupiter is pretty far away from the Sun. Its orbit is equal to about 12 Earth years. Jupiter's average temperature is 165 Kelvin or minus 108 degrees Celsius, which is really cold. Meanwhile, hot Jupiters orbit their stars in as little as in 4 days. That's a lot quicker than Mercury's 88-day orbit around our Sun. And a hot Jupiter's average temperature can be around 1,000 Kelvin. Hot Jupiters are the easiest type of planet to detect with the radial velocity method. This is because a hot Jupiter's high mass and its close proximity to its host star both make the host star wobble. Remember that the wobbling is from the force of gravity on the star by the planet. This force of gravity is equal to a number called the gravitational constant times the mass of the star times the mass of the planet, all divided by the radius of the planet's orbit squared. Making little m bigger and r smaller both make the force of gravity bigger. A hot Jupiter can also be detected by the transit method because it has a large radius, so it can block a significant amount of the host star's light when it transits. When astronomers discovered 51 Pegasi b, the first exoplanet found around a main sequence star, they were baffled by the combination of its 4-day orbital period and estimated mass about half that of Jupiter. The discovery of a gas giant orbiting close to its host star didn't match up with astronomers' ideas of planetary formation at the time. However, the discoveries of more and more hot Jupiters forced astronomers to realize that this type of planet is actually pretty common. Astronomers who focus on planetary formation models accepted that their theories were incorrect and worked hard to revise them, because that's how science works. One idea astronomers have for how hot Jupiters are so close to their host stars is the migration hypothesis. This hypothesis says that hot Jupiters form beyond the frost line, the distance from a star where it's just cold enough for chemical compounds like water or carbon monoxide to turn into ice. Sometime after formation, the planet migrates inwards towards the host star due to gravitational interactions with the planetary disk or another massive planet in the system. Another trend in discovered exoplanets are planets astronomers call super-Earths. These are exoplanets that are larger than the Earth, but smaller than the typical gas giants. They can also be called mini Neptunes. Most astronomers agree that they have an upper bound of 10 Earth masses. But the term super-Earth, however, doesn't have anything to do with the planet's composition, temperature, or distance from its host star. This term is only based on the planet's mass. However, if astronomers can estimate the density of a super-Earth, they can estimate its composition. Super-Earths with high density are likely completely rocky. Super-Earths with medium density could have a rocky core surrounded by layers of gas or be mostly made of water. Finally, super-Earths with the lowest densities are likely gases like Neptune. Super-Earth and Neptune-sized exoplanets are the most common planet candidates. This is a plot of Kepler planet candidates. So all of these discoveries were made with the transit method. Most super-Earths are in fact found using the transit method. Of course, there are some super-Earths that have also been found using the radial velocity method. And in May this year, a very exciting and unusual super-Earth discovery was made. A super-Earth called the August 2018 BLG0677 was found using microlensing, a method that rarely finds exoplanets. Microlensing is when light from a faraway object, usually a star, is actually bent by a closer object like a star with a planet around it. This bending happens because the closer star's gravitational field is affecting the way the light from the faraway star travels. If there's a planet around the closer star, the bending of the light will look a little different than if there wasn't a planet there. You can learn more about the microlensing method from the links in the description. Most exoplanets around 10 Earth masses are thought to be super-Earths of mixed or gaseous composition. However, there can be 10 Earth masses exoplanets that are completely terrestrial. Planets in this category are called mega-Earth. Kepler-145b is an exoplanet classified as a mega-Earth. Its radius is only 2.65 Earth radii, but its mass is 37.1 Earth masses. That's one dense planet. The last type of exoplanet we'll talk about today is called a rogue planet, which I think sounds pretty cool. It's basically a planet with no star and can have any composition. A rogue planet may have been ejected from a planetary system somehow, or maybe it was never gravitationally bound to a star at all. Not much is known about how planets go rogue, but maybe you can help solve this mystery one day. Since so many exoplanets have been found, astronomers now say that at least half of all the stars in the universe have at least one planet. And there are plenty of planetary systems that have been found with 2 or more planets. My favorite exoplanetary system is the TRAPPIST-1 system. TRAPPIST-1 is a red dwarf star, and astronomers have confirmed that there are 7 terrestrial planets orbiting it. All 7 planets orbit the star closer than Mercury orbits the Sun. But since TRAPPIST-1 is much cooler than the Sun, 3 of these planets are actually in the habitable zone, which means that they're at the right distance from their star to have liquid water on their surfaces. The habitable zone is also sometimes called the Goldilocks Zone. And if a planet is in the habitable zone of a star, it is not too hot, it is not too cold, it is just right. The possibility of liquid water being present on a planet is also really exciting because it means that there's a chance that the planet could have life. Scientists and science fiction creators alike love to imagine what exoplanet life could look like. In reality, a planet's ability to support life is a lot more complicated than just being at the right temperature for liquid water. There are lots of other necessary factors to consider, like whether the planet has a strong enough atmosphere to protect it from dangerous stellar radiation. The study of life in the universe outside of Earth is called astrobiology. And if you're interested in the origins and likelihood of extraterrestrial life, you can become an astrobiologist. Even though the possibility of life on exoplanets is complicated, it's still fun to imagine. Try imagining your very own exoplanet. I personally like thinking of planets that have life. But you could also come up with your own ideas of how a hot Jupiter, super-Earth, mega-Earth, or rogue planet looks like. And as a fun activity, you can even create some artworks of your own planet. Here are some exoplanets imagined by my friends from the Lawrence. Well, that's all for today. I hope you enjoyed learning more about exoplanets. Be sure to give this video a like and subscribe for more science content. I will see you later and keep asking big questions about the universe. Bye!